Hello, and welcome to today's lesson. We're in our second unit of area and volume, and we're looking at our first lesson here. So now we're moving into three-dimensional shapes. So in today's lesson, we will identify and draw geometric solids, okay, learn some new vocabulary, and visualize the parts of three-dimensional shapes. So we'll look at those pieces as a part of today's lesson. So when we talk about space, unlike a flat plane and line, space cannot be contained into a flat surface. Unfortunately, we're looking at this in a flat, screen or on a flat board, but we really have to think about or look at the idea of three-dimensional space. So we have length, width, and depth overall, or also known as height. So when we look at a prism is a type of polyhedron, okay? So it's not a polygon, because a polygon is two-dimensional. A polyhedron is a three-dimensional shape with two faces called bases. Okay, so we always want to identify what's the base shape here. And they are the two shapes that are directly across from each other. They're parallel to each other when we're looking at our prisms right now. Okay, they are congruent parallel polygons. So when we're looking at a shape, we always want to identify where they are. It might not be what the shape is sitting on is the base of the shape, but we have to look for those two congruent parallel polygons. So when we look at this shape here, our two congruent parallel polygons they look like squares, but we would probably want to say a rectangle in this case. In this case, we've got the two triangles that are congruent parallel polygons. And in this shape, we've got our two hexagons that are congruent parallel polygons. Excuse me. I think I'm allergic to school. Okay, so now when we look at some of our other terms that we have to define, we have to define what we call a lateral edge. A lateral edge is a measurement that connects the two base values. A lateral face is the shape that you get when you're connecting the two bases. If you look at it as a two-dimensional shape versus a lateral edge, which is just a segment of a line. And then we have our base values. Once again, our bases are the two congruent parallel polygons. So those are some of our new terms that we have to know and understand and be able to use in this unit. Okay, so when we look at a right prism, so we can have what we call a right prism, we can have an oblique prism, and we have to understand some of the differences between these two. So when we look at a right prism, it is a prism whose lateral faces are rectangles, or in other words, the lateral edges are perpendicular to the base. So when we look at the shape, every one of these lateral faces as we go around, those lateral faces are all rectangles. They're rectangles because of the perpendicular distance or the perpendicular angle between the base and a lateral edge. So when we're looking at prisms, we call the height of a prism the altitude. And it's always important. We remember this from our last unit as well. Heights always need to be perpendicular to the base. And it's no different when we're talking about a prism. In order for it to be a right prism, we have to make sure that our lateral edges are perpendicular to our two bases, in this case the hexagon. Over on the other side here, we have what we call an oblique prism. Okay, we have our congruent parallel triangles. Okay, so that makes our base of the shape. But if we notice, this prism is tilted on its side. We don't have a perpendicular angle between the base and the lateral edge. But once again, we're always trying to measure height, or in this case, we call it altitude. That measurement of height does have to be perpendicular in order for us to do any mathematical calculations for those values. So now when we're looking at a shape, we want to be able to identify the base or identify a base, identify lateral edges, a lateral face, naming an altitude. Now what we want to remember is when we're naming shapes, we have to go in order around the shape that we're trying to name. It doesn't matter what letter we start with. I can start naming this bottom base, the bottom hexagon, with G, and as soon as I start with G, I either have to go to H next or I have to go to L next. Okay, I'm going to go clockwise around the shape. So the bottom base would be named GLKJIH. Okay, so that would be the name of the base hexagon in this shape. Okay, remember, lateral edges connect the two bases. They're line segments. So when we're looking at line segments, we would want to use a two-letter designation. DI would be one lateral edge. I could use GF as another one. Okay, but when we're talking about a lateral edge, we want the two end points of that line segment. If I'm naming a lateral face in this case is a rectangle. It doesn't always have to be a rectangle, but a lateral face is one of the shapes that connect the two bases. So it's not just the segment that connects the two bases, but once again, it's the shape that connects the two bases. And I can name this lateral face, once again, pick any point in the shape and work your way either clockwise or counterclockwise around the shape. So I'm actually going to go, let's go counterclockwise just to show that we can go in either direction. So I'm starting with K, and I'm going to go KBAL. And that is the name of a lateral face. Now, name of an altitude. Okay, altitude, it's always important. Look for that perpendicular angle when we're looking for and finding altitudes or the height of the prism. And then we can name it from there. So we have ID, we have HL would be another altitude. And in this case, the altitude and the lateral edge are truly the same thing. They are altitudes, they are lateral edges. Okay, now that will be different in this shape, which is a oblique prism. Okay, so first I'm going to name a base, and remember there's always two bases, so I'm going to name the upper base here. Once again, pick a point, work either clockwise or counterclockwise around the shape. So one of our bases is OMN. A lateral edge is a edge of the prism, okay, line segment connecting the similar spots in the two bases. So we've got OP, or PO is a lateral edge here, okay, and a lateral face Okay, a lateral face, naming any of the three shapes that are connecting the two bases. Okay, we pick a point. I'm going to name this face, okay, on the back right side. I'm going to start with R. I'm going to go RQNM. So RQNM, and I've named the lateral face of that shape. Notice we can't really name the altitude unless we put a point out here in space to help us name the altitude for the oblique prism. Okay, now let's try to draw some three-dimensional figures. So if we're having to draw them, we want to understand how we can draw them in the easiest way possible. So if I'm drawing a right triangular prism, the first thing I want to do is draw the two congruent triangles. Okay, those are my two bases. I'm drawing my two bases, and then what I want to do is connect all of the similar parts of that shape. And then I've drawn a right triangular prism. Now, if I want to draw an oblique rectangular prism, okay, once again, now it's going to look weird because they're going to look like parallelograms, but the top and bottom here would truly be the similar rectangles. And we have those, and what we would want to do is any part of the shape that is hidden by another part, we usually use dotted lines to show that that is a back value. And then the hard part here is making all the connections. You know, we're connecting this, we're connecting these two, and since that's just outside, you know, and that's what makes this drawing a little more difficult, is to connect all those pieces. Okay, not a great oblique rectangular prism on my part, okay, but you can see how you always want to start with your base shape, draw the base shapes in first, and then connect them from there. Okay, now pyramids, another three-dimensional shape that we work with a lot is a pyramid. Now notice, all three of these are pyramids, and the only difference is the base of the pyramid. We can have a square or rectangular pyramid, we can have a triangular pyramid, and we can have a hexagonal pyramid. Okay, we can really actually have any polygon shape as the base of the pyramid as long as they all work up in a regular measurement to that central point. Okay, the altitude or the height of the pyramid is the perpendicular segment from the vertex, the upper point, down to the base. Okay, and that can connect in different spots at the base based on the shape that we have. Okay, we can actually see an altitude drawn into this hexagonal pyramid. Okay, so when we look at a pyramid, the lateral faces are all triangles in a pyramid, and the number of triangles is based on whatever base shape that you have. And notice the important part, there is only one base to a pyramid. So if we want to name and draw the shape, a triangular pyramid has a triangular base. And then everything works up to the central point from there. A rectangular pyramid is going to have a rectangular base. And then you have your central point that you're drawing all of your pieces to from there. Okay, now, cylinder. An example of a cylinder is probably the easiest one is a soda can. You know, a can of soup. Any can item that you would find at the supermarket. Okay, what are the bases of a cylinder? The bases are circles. And once again, they're connected by what we call our lateral edge in this shape is actually still a rectangle that wraps all the way around the cylinder. So if we're cutting and laying a cylinder flat, it would look like our shape on the right. Okay, a cone. So when we think about a cone, an ice cream cone, I don't know why I'm blanking on other shapes for cones. The base of a cone is a circle. It's got that singular vertex, so it's very similar to a pyramid. So we can see that cylinders are similar to prisms, and cones are similar to pyramids. And then finally the sphere, looking at any globe, is truly a sphere. Okay, we want to show that there is some depth. Okay, central point of that as well. And then a hemisphere. Okay, we're just showing that it is a sphere truly cut in half. Okay, so we're always looking at how can we cut these shapes up into different pieces. What do we have overall? And a dome is a good example of a hemisphere. Okay, next thing we want to talk about is cross sections. We can cut cross sections through shapes in different ways, and we just want to understand what would the cross section look like, because the cross section becomes a two-dimensional shape. So if we're cutting it and we're opening it up, so here we have a triangular prism. A cross section, if it is parallel with the base, would be a triangle. If we did a cross section top to bottom, it would be a rectangle. Okay, we have a rectangular prism here. Okay, parallel cross section to the bases is a rectangle. Okay, if we did a cut through the top to bottom, we would also see a rectangle. We can see the cross sections of a pyramid, cross section of a cylinder, and we're always just trying to see what type of shape does it make. Okay, here we've got a circle, here we have a triangle, and then, if we cut in another direction, would we make a different shape? If we cut a cylinder top to bottom and open it up, it would actually be two rectangles that we would see overall. So now, if you're trying to draw a shape, here's always the best thing that you can do. Okay, drawing pyramids, you can actually start with a circle. You're actually starting by building a cone, and then you're drawing as many lines down you need for your base shape, and you can work from there. Drawing a cylinder, starting with the two circles connecting. We're always trying to dot the line if it's behind to help show some depth. Drawing a prism, drawing a cone, and drawing a sphere and hemisphere. Okay, so we can do, and we're always trying to show the depth with the dotted lines back behind the shape. And here's just some more examples. The reason why I want to look at this page is important. Notice this hexagonal prism. It's not sitting on its base, but you always have to identify what are the two congruent parallel polygons. And that's what we name the shape based off of. This pentagonal prism down here. Once again, the two congruent parallel polygon shapes. Same thing with our triangular prism there. Okay, so that concludes our lesson for today, looking at naming, defining the pieces of three-dimensional solids. Thank you and have a good day.